Hello, everybody. Welcome back. We are still at home, I see, and looks like we will continue doing that for the conceivable future. So let's go ahead and get comfortable and get through the start of this quarter. What are we going to be doing? We're going to be starting with our create task, of course, and then just to kind of give you an overview of what we're doing down the line, we're going to take a look at something called regular expressions, which I think is a really helpful concept to have a hang on. We're going to revisit sorting algorithms because I assume a good portion of you didn't actually take a look at that. And then, depending on timing, we're either going to do a final project or we'll cover another topic, which we'll determine as we get closer to that date. Trying to stay fluid. If we end up going back to school, obviously this will change a little bit. All right, let's go ahead and talk about the create task. I want to just touch on this real quick before kind of moving on. These are some of the common questions I received. I cannot help you with individual questions or give you direct feedback on your code. So if you send me a piece of code and you're like, Mr. M, this isn't working, what do I do? The only thing I can tell you is, hey, find someone who isn't me to take a look at, who is one of your classmates. They are allowed to help you. I'm not. So I can answer questions about the prompts, like what do they mean by this, or can I have an example? I can find you an example. Or I can talk to you about general coding things like how do you structure a piece of code or how do you put comments and things like that. But I can't give you direct feedback on what you wrote. You can collaborate with other people in your class, specifically on the code. Now, I'm not going to try to pair you up. It's up to you. If you would like to work with somebody else, you can do so. If you don't got nobody and you're not feeling like reaching out, that's fine. You can do it by yourself and do just as well. Just, I would recommend, if you can, get someone else in the class to take a look at your code. And maybe we'll set that up or set up an option for that closer to the end of the project. You cannot collaborate on anything other than the code. So you can't write anything together or take the video together. Your videos can't be identical. And we'll take a look at that in a sec. All right, so week 4 of Coronication, what are we doing? We're going to be going over the criteria for the create practice task, or actually the real task. And we're going to take a look at the 2 assignments that are going to be due at the end of this week and how you can go ahead and get started on the task. Due this Sunday, the 26th, are going to be 2 assignments. Let's take a look at them right now. The first one is titled, Is it an algorithm? Is it abstraction? This is directly from the survival guide, which we already took a look at a previous week. So if you didn't do that, please take a look at the survival guide. It's posted on MyMCPS underneath the create task in modules. What are you going to be doing? You're going to go through and you're going to score some of these algorithm submissions and tell me if they are algorithms or not. In order for something to be considered an algorithm and earn a point on this particular project, it has to have the following criteria. It has to have 2 or more supporting algorithms within it. It has to have at least one mathematical or logical concept used in one of those 2 algorithms. So having an if statement or adding something, dividing, anything like that counts. And at least one of the included algorithms, you have to explain how it functions independently. This will be really, really easy, hint, hint, nudge, nudge, for your actual project if you break these up into individual functions. If you don't have to, it's not required, but if you do, it makes it really easier to track the flow of your program. It makes it a lot easier to write about. So I'll actually help you with this first one. Let's take a look. On event, button 1 is clicked, then we'll set some property. On event, something else is clicked, we'll set some other property. Well, it's really unclear what this does together. Maybe this accomplishes something together. I don't know. But it seems like we have two things that are just a single line of code. So that's strike one. It's unclear what the purpose is. Strike two, neither of these to use any sort of math or logic concepts. So this does not earn the point for those two reasons. It's unclear what the cohesion here is, and it's kind of hard to call this really an algorithm. It's a single line of code, twice. All right, so it's up to you to go through the rest of these and figure out for yourselves which ones are and which ones are not algorithms. This one, you're going to take a look at the criteria for something to be an abstraction. Basically, really straightforward. It's got to be something you yourself wrote. That's a function. Easy. Selected code is a student-developed abstraction. Anything inside an on event, you already know, talked about this, doesn't count. So hint, hint, nudge, nudge, this first one, it's an event. Anything inside an on event, automatically out. Doesn't count. It's got to be a standalone function. And lastly, you do have to manage complexity of the code. So that's a very vague idea. You have to explain to the AP graders how your abstraction manages the complexity, and that could be anything from just reducing how much code you have to write to allowing you to call the same piece of code multiple times or in different settings. So you could potentially say this does manage complexity, but again, does not count because it's a non-event. All right, so that's your first assignment. Now let's take a look at the second assignment. You're going to take a look at a sample and you're going to try to score it for me. In order to score it, we're going to use the AP provided scoring guide, scoring rubric, and you're going to go through and give it a point, either 1 or 0. You either get it or you don't for every single one of these, based on the rubric that's pasted below. So the document here contains all their answers, and the video here contains their little video that you're required to have. You're going to go through and you're going to tell me, does it do these two things inside their video? You know, does it demonstrate yada, yada, yada. You guys can read. Down here, you have to tell me if it earned or did not earn the point for the row and why. Here, you can paste your response. You don't have to do anything for the video. I have seen the video, but for the written responses, you might want to paste the relevant parts, like the parts that made you make your decision. Where in their response did they actually address these things, or did they not? So please put some time into this and think about it carefully. Look at the do not award points column. If they did something of this ilk over here, they don't get a point, okay? So let's take a look at some samples together so that you guys have some idea. And all of these are posted on MyMCPS under the Create task inside Modules, so you can take a look at these on your own. Let's take a look at this one real quick. This is sample C from 2017. It got all but 1 point. I'm not going to talk about the video. The video is really straightforward. It's really hard to miss a point on the video as long as you submit one. The video demonstrates the running of at least one feature of the program. In fact, your whole program doesn't even need to function. As long as some of it works, you can take a video of it. And the response identifies the purpose of the program. So as long as you make it clear what you're going to do and show it doing at least something in the video, you get a point here. Really, really easy. So I'm not going to belabor this one. Take a look at this one. In 2B, this is now going into the written responses. You have to describe or outline steps used in the incremental and iterative development process to create the entire program. So the actual prompt, remember, is multi-part. So for this question, the actual prompt asks you to outline the development process as well as point out 2 points where you had trouble or difficulty or saw an opportunity and took advantage of it. You have to do both, so make sure when you write your own, you kind of break it up into in your head how you're going to address each of those points. If you just address one, you're going to miss a point. So in this particular case, they do a good job. They say how they went through and wrote the program, yada, yada, yada. They also point out 2 places where they had problems and how they addressed them. So it's very well written, and I advise you to take note of their layout and maybe emulate it. Could be a good idea. And again, the second part where they identify problems, they do that, so they get a point for that as well. Here they ask you to capture a piece of your program code that has an algorithm. Remember, your algorithm has to have two smaller supporting algorithms that help it accomplish whatever it is it's trying to do. You have to mark it with an oval. To mark it with an oval, I'll show you there's a code selecting tool we'll use. And you have to basically describe how that algorithm functions independently. And then what all of them together accomplish. So real straightforward. They have an algorithm. It has two supporting algorithms. They have math or logic in there. They explain what it does and how it does that. And then they explain its job in the actual program. Real straightforward. Nothing too crazy here. Now it is a lot of parts. You don't want to miss any of those parts, but none of the parts are ridiculous. All right. Now there is some partial credit here. So for row 5, if you know, you have to have a algorithm that has a logical concept, explain how it functions, and describe what it does. If you look at row 6, this talks about it having 2 or more. So if you accidentally don't have 2 or more algorithms, like you have just one by itself, then you could still earn points for row 5, but not row 6. So that's the distinction there. Lastly, we have our abstraction. Again, if it's a function and you wrote it, you get the point. If it's not, you don't. Really, really black and white here. And then you have to explain how it manages the complexity. So here they talked about not having to repeat code. That's one way to manage complexity. And lastly, there's a section for you to paste your program code. I did not include that in the sample. So there are 2, 3, 4 other samples posted, and there's also a link to the AP site, which has tens or dozens of them. Feel free to look through these and look at some of the common pitfalls. For instance, this one, well, it's supposed to describe the steps as you built up your program, but it doesn't do that. It just talks about problems. A lot of you did that in the practice prompt we did for our 4-pager, right? So please make sure you address every part, right? I'm not going to belabor this. Please go through this on your own and take a look and email me if you have any questions with it. Lastly, there is a code.org practice complete submission posted as well. This one has the video, it has like a really, really strong response, and the code all together. So you can take a look at this if you're looking for like a 10 out of 8 submission. This is probably more than is expected of you, but why not shoot for the sky, right? So that's something to check out. So here on my MCPS, just to show you, underneath modules, here are the 2 assignments that are due April 26th that you need to complete this week. And right below is the create task, where we have all our various things. So we have some tools for you to take a video, which we'll talk about later, the template if you want to get started, the survival guide, which kind of has an outline. We'll take a look at that more later, and I already talked about it. The rubric, and then all of these samples. Please check those out. Okay, that's all I've got. Please make sure, if you have any questions, you email me, and I'm available for Zoom conferences. If you would really not like to type, you'd want to see me face to face and have me explain something to you, we can do that. But you gotta let me know that's something you need. As of now, I'm not planning to have any group Zoom conferences. I will update you if that changes. All right, guys, stay safe out there and have a good week. Let me know if you have questions. Goodbye.